Hi everyone, today we're going to cover the three main ways to graph linear equations. So the first way to graph a line is by using a table. The second way is by using the intercept method. And the third way is by using the slope-intercept formula. And this is also y equals mx plus b. So first we'll practice graphing a line using the table method. So what you're going to do is you're going to plug in a few values for x to find a few values for y, and then you're going to plug those points on the graph and then connect the dots to make the line. So let's say we have the equation y equals x minus 2. So we're going to make a little table for x and y values. So you can choose any x values you want, but we're just going to do -1, 0, 1, 2, and 3. So you're going to plug this into this equation right here, and you're going to find the y values. So -1 minus 2 is -3, 0 minus 2 is -2, 1 minus 2 is -1, 2 minus 2 is 0, and 3 minus 2 is 1. So then you're just going to plug these values into this graph. So first we're going to plug in -1 comma -3, -1 comma -3, then 0 comma -2, 1 comma -1, 2 comma 0, and 3 comma 1. And then you're just going to connect these points with a line like this, and there you have your equation or your graph. So now we're going to move on to the next method, which is the intercept method. So in this method, you're going to find the two intercepts, the x-intercept and the y-intercept of the graph, and then you're going to plot those 2 points on the graph, then connect them with a line. So let's use the same equation as before, y equals x minus 2. So first we're going to find the x-intercept. And if you remember from the previous video, the x-intercept, y is always 0. So you're just going to plug in y equals 0 to this equation. So 0 equals x minus 2, and x equals 2. So therefore, the x-intercept is 2, 0. So let's plug this point in, 2, 0. Then we're going to find the y-intercept. For the y-intercept, x is 0. Just going to plug that into the equation. Then we get 0, -2. And we're just going to plot that too. Now we have these 2 points, and we can connect them with a line. There we go. So this is the graph of this equation, and it's the same as the one before, as you can see. Okay, now we're going to move on to the third method, which is the slope-intercept method, which is y equals mx plus b. So basically you're just going to look at, convert the equation to this form and then find m and b. And m is the slope and b is the y-intercept. So let's use the same equation as before, y equals x minus 2. And we're going to compare this to this y equals mx plus b equation. So m right here is the slope, and it's 1. So m, the slope, equals 1. And remember, the slope is the change in y over the change in x. And in this case, since it's 1, it could either be 1 over 1 or -1 over -1. But that all equals 1. Now we're going to compare the b value, which is the y-intercept. So b, or the y-intercept, is -2. So that means the y-intercept, x is always 0. So this point is 0, -2. So why don't we plug this equation into this point into the graph first. So 0, -2, that's right here. Then we're going to use a slope. And the slope is rise over run. And it could either be 1 over 1 or -1 over -1. So let's go with 1 over 1 first. So we got up 1, and then to the right 1. Up 1, and then right 1. Up 1, right 1. We can keep going. Or we can go -1 and -1. So we can go down 1 and then left 1, and we still get this point. Then we're just going to connect all of these points. There we go. And we get the same graph as the two previous methods. I will give some example graphing problems. So the first one is y equals 1/5 x minus 4. And since this is already in the slope-intercept form, y equals mx plus b, all we have to do is find the slope and the y-intercept. So the slope m is 1/5, and the y-intercept b is -4. So first we're going to graph the y-intercept, which is -4. It's right here. Then the slope is change in y over change in x. So we're going to move up 1 and to the right 5. So 1 and then 1, 2, 3, 4, 5. Up 1 and then right 5. 3, 4, 5. Up and then. And 1/5 is also equal to -1 over -5 because the negatives just cancel out. So we can also use -1 over -5. So we go down 1 because it's -1, and we go to the left 5 units because it's -5. So we go down 1 and then to the left 5. Down and then -5. -1 and -5. We keep going until the very end. Then we connect all of the dots. Then we get the graph of y equals 1/5 x minus 4. Now the next one is x plus y equals -3. And we can also convert it to the y equals mx plus b form by going y equals -x minus 3. And that would also work, but another way of doing this would be the intercept form, the intercept method. Since x plus y equals -3 and there are no fractions and there are no coefficients, so it's really easy to do the intercept form. So the x-intercept is when y equals 0, so x equals -3. So we have the point -3, 0. And then the y-intercept is when x equals 0, so y equals -3. And we have the point 0, -3. So let's graph these 2 points. And 0, -3. So all we're going to do is we're going to draw a line. There we go. And either method would work. This first y equals mx plus b method would also work, but the intercept is a lot easier since we don't have to rewrite this equation in the mx plus b form. Next we have 6x minus 3y equals 1. So first we don't really know if the intercept form or the y equals mx plus b form is going to work, so we're just going to start with the slope-intercept form. Okay, I'll write that actually in a different color. So -3y equals -6x plus 1. Then divide by -3 on all sides and you get 2x minus 1/3. So from this we get, let's write it in orange, we get slope is 2 and the y-intercept is -1/3. So let's try graphing this. -1/3, which is about here maybe, and the slope is 2, so we go up 1, up 2, 1, and then 2, and then to the right 1, about here. And this is also equal to -2 over -1, so we can go down 2, -2, and go left -1. It's about there. So I'm just going to draw A. Pretty much right. And then, since we're not really 100% sure if this is close, because -1/3 is a fraction and we're not exactly sure if that point is -1/3, so we can check. We can check by plugging in points. So we can first try the intercept method. And since we already know the y-intercept, which is right here, b equals negative 1/3, let's just find the x-intercept. So that's when y equals 0. So 6x equals 1. So x equals 1/6. So it's 1/6, comma 0. And let's see if that's, yeah, that point looks about 1/6 right here. Okay, but we're not really sure because we don't even know if that's 1/6. So let's just try one more point. And this is when the table method might come in handy. So we've got x and then y. So we can just try any point. I'm just going to do -1 because it seems like a good number. So -1. Plug that in. -6 minus 3y equals 1. -3y equals 7. And y equals -7/3, which equals -2 and 1/3. So at -1, it's -1, 2, and 1/3. Does that seem about -2 and 1/3? Yes, it does. So we can say that this graph is very close, or not exactly perfect, but close enough. And so this example is just to show that you can use all of the methods just to check if the graph is straight, especially if the y-intercept or the slope or the y-intercept or the x-intercept, they're not whole numbers.